Okay, you can't fill in that blank if you don't know what it relates to. Right? Yes, you can Google and see how to solve it, but you won't know what to Google if you don't even know where to start. Right? That's the key piece. Are you going to remember everything that we talked about all school year? Absolutely not. Do I remember everything I talked about in high school? No. So what do I do when I don't remember? Right? I look at my daughter's textbook, I Google it, I do some reading, and then my brain goes, oh yeah, I kind of remember how that works. And then I can then put that back together. That's learning. Okay? That's the piece that's important. So we don't need to necessarily memorize everything that we've ever learned. We need to know how we could recall that information that we've learned. Okay? So we want to, by the end of this week and starting on Monday, be able to sort of make those connections with the different pieces that we've talked about. There is one big chunk of sorting that we haven't looked at yet. And that's how do we decide if something is linear, quadratic, or exponential if we are given the table. Okay? We know how to take a quadratic function and create a table, or take a linear function and create a table. But how do we know that the table that's being given to us is quadratic, is linear, is exponential? All the other forms we know how to work in between. Okay, so here's what we're going to look at today. Let's say I have a table. This is the information that's provided to me. Okay? And I want to decide if this table of data is giving me something that's linear, quadratic, or exponential. Right, but Mrs. McKinney, why in the world would you ever need to decide that? Okay, well, let's decide. I'm a business, okay, and I want to see what's happening. Are my profits continuing to rise? Or at some point, am I looking at some information that my profits are going to curve off and then go back down? Okay, that's where you might need to make those connections. What's happening with this data that I'm getting? Remember talking about data analysis, right? Being able to interpret that information we're looking at. Okay, so if we want to decide what situation is in, we have some options. So can anybody give me maybe an option that they would just guess or they would try if they wanted to decide what this data is representing? Bailey, what might you try?
Like, if we're talking about profits, like, we could try seeing where we started versus where we're at now, and then...
And how would you look at that, other than just looking at a table and hoping for the best?
By using a graph and plotting it.
Okay, so we could graph this and plot these points and see what those points look like. If they look like a line, what type of data are we talking about? Linear. If they look like a U-shape, what type of data are we talking about? Which is a quadratic. If we see something that's not swooped shape, what type of data are we talking about? Exponential. So that would be an option. Okay? That just requires you to take an additional step of graphing. I'm going to show you how to get there without having to graph. Okay? And here's what you're going to do. You're going to go right here. And you're going to ask yourself what you have to add or subtract to get to the next number.
Plus 2.
7 plus 2 is? 9 plus?
2.
11 plus?
2.
Do we see how all three of those values are the same? Okay? This is a plus 2, a plus 2, and a plus 2. When all three of these values are the same, it is a linear function. Okay, so when we're adding or subtracting the same value all the way down, this is a linear function. The reason why it's linear is actually what we've heard over here when we're talking about a graph. Linear functions have a constant rate of increase. Okay, are we okay there? How about if we have this table?
-1.
Yes, Livia?
If we wanted, because graphing would work every time, right?
Yes, but some of the numbers are going to start to get weird.
Okay.
Okay? And sometimes you can just visually look at it, right? And I'll show you what I mean by that in a minute here too. So what do we do to get from 1 to 0? Subtract 1. From 0 to 4.
Add 4.
From 4 to 9.
Add 5.
I skipped a value in here. Sorry, guys.
Oh, she lied.
I didn't lie. The table's right. I just skipped a value. We could keep going. We could have 416. Got a little excited for math, okay? Okay, from 1 to 4.
+3.
Plus 3. 4 to 9.
5.
9 to 16.
7.
Do those match?
No.
No.
So can this be linear?
No.
No. So we're going to check again.
That's
Negative 1 to 1.
2. Right. 2.
Now it's going to be
Plus 2.
even.
+2.
Because all those equal.
Okay, so now it matches the second time we go out. If it matches the second time we go out, it's quadratic. Quadratics have a degree of 2, so they match the second time. Cubics have a degree of 3, so they would match the third time.
That's
Okay, so right here, because they match on the second check. Are we okay there? Now, visually, sometimes my students just look at this and go, oh, 4 squared is 16, 3 squared is 9, 2 squared is 4, and so they can just tell it's quadratic. The numbers just aren't always that pretty. Today, we're just starting with the very basics. Okay, you'll see they start to get a lot messier, especially as we move into the activity on Friday, and you'll kind of not like me very much for it. Last one.
What if they don't equal at all?
Yeah, so what if they don't equal at all? What does that leave us with?
Exponential.
Exponential, but here's what exponential does.
Wait, what was that last one?
Quadratic.
What you said?
Uh-oh.
Good stay recorded.
+2. +4.
Guys, you're not paying attention.
+3.
Okay, so let's check again. Do you see how it's doing the same thing each time? same pattern. When it repeats the same pattern, it's exponential.